Hello guys, I hope you all are doing well. In today's video, we are going to learn about quadratic function. Please pay a lot of attention because it's a very important topic and you must learn it properly. Okay, so let's start. So any quadratic function looks like ax square plus bx plus c. Okay, so this is the general form of a quadratic function. Always remember that a here can never be equal to 0. A here can never be equal to 0. Why can't it be 0? Think logically. If you substitute a as 0, your function becomes 0 times x square plus bx plus c. 0 times x square will be 0. So y equal to 0 plus bx plus c. So y equal to bx plus c. So it becomes y equal to bx plus c. Now if you observe, this is a linear function, right? The power of x here is 1. The highest power of x here is 1. So it becomes a linear function. That's why a is never equal to 0. So the general form is y equal to ax square plus bx plus c. Okay. Now you have to pay attention over the fact that any quadratic function, if you sketch it on the graph paper or if you sketch it on Desmos or let's say GeoGebra, you will observe that it looks like a parabola. I'll show you quickly. So yeah, let's take two examples. The first example is x square minus 4x plus 3. Okay, now if I hide it, if you observe, this looks like a parabola. Okay, now let's take one more example. Let's say it is minus x square plus x minus 6. Okay, now if you observe, I'll change the color. Let's say the color I'm using here is red. Okay, yeah. Now if you observe, the red graph also looks like a parabola, but it is facing downside. Now why is it so? Okay, if you observe, the first function is x square minus 4x plus 3, and if you observe the second function, it is minus x square plus x minus 6. The conclusion that I'm trying to make here is the fact that the graph either looks like this facing upwards or it looks like this facing downwards. Okay, so it depends on the coefficient of x square. If the coefficient of x square is positive, if a is positive, the graph looks like this, which is a smiling face. Okay, and if the coefficient of x square, if it is negative, the graph looks like this, which is a sad face. Now one more interesting thing that you should know or you should observe is the fact that the quadratic curve, the parabolas are always symmetrical. Okay, so the line that I've drawn, if you see the right hand side of the graph graph from the axis of symmetry, let's say the yellow side that I am highlighting here, it is exactly same to the left hand side of the axis of symmetry. It is exactly same on the left hand side also. So if you compare the right hand side and left hand side, if you compare the yellow highlighted part and green highlighted part, they are exactly the same. The graph is symmetrical. So this line that I've drawn exactly in the center is known as axis of symmetry, AOS, axis of symmetry. Okay, now there is one more interesting thing that you should know. The graph has a turning point. So this red point that I've marked here is nothing but the turning point. Okay, so the graph was coming like that, it reached the red point and then it turned. Okay, similarly, if you see the second example, the graph was going like this and then it stopped on the turning point, and from the turning point it took a turn and it's going down. Okay, what I mean to say is, let me erase this and then maybe show you. Oh, sorry, the whole graph got erased only. Yeah, let me erase this. Yeah, so if you see, the graph over here was coming down, and from this point it's going up and up. So this is the similar thing which is happening on the second graph, which is on the right hand side also. So basically this red point is known as the turning point. Now there is one more interesting name for this. This red point is also known as vertex. It is also known as vertex of the parabola. It's also known as vertex of the parabola. Okay, so basically why this is important to know is the fact that, let's say there are two possible cases. Okay, let me draw the Cartesian plane. Let me draw the Cartesian plane. Let's say this is your y-axis, this is your x-axis, and that's your origin. And let's say this is the second case. Again, this is your y-axis, that's your x-axis, and this is your 0. Okay, now there are two possibilities, right? What are the two possibilities? Either the graph will look like this. Okay, it will face upwards, or it will face downwards, or it will face downwards. There is no other possibility, right? There is no other possibility. Now what is the domain of the function? So domain of any quadratic function, let's say the function is Ax² plus Bx plus C. So there is no restriction on x, right? There is no restriction on x. So the domain of the quadratic function, right? The domain of the quadratic function is all real. The domain of the quadratic function is all real. So all real value can come and they can be substituted instead of x, right? So the domain is all real. But what is the range? What is the range? If you see the first case, the least value is here on the vertex, like the turning point. That's your least value. So this is the least possible value of the graph in the first case, right? And what is the maximum value? What is the maximum value? If you see the graph is going up, up and up and up. So it's going, it's like this graph, and it's going up till infinity, right? So what is the range? The range here is the vertex point, whatever the vertex point is. Let's say the coordinates are h comma k. So what is the range, guys? What is the range? The range will be h is the k is the least value, the y-axis value. K is the least value, and the highest possible value is infinity. So this is your range. And if you see the second case, you have the turning point here, and that's your maximum point, right? The graph is not going above this point, so this is your maximum point. But if you see, the graph is going down, right? The graph is going down. So it is like this, and it's going down and down. So what is the maximum possible value? Let's say if this point is h comma k again, then what is the range? The range here is it's starting from minus infinity. I mean, the least possible value, since it's going down and down, the least possible value will be minus infinity. And what will be the maximum possible value? The maximum possible value will be k. So that's the range. That's the range of a function. Okay. Now, there are three forms of a quadratic function. There are three forms of a quadratic function. What are the three forms, guys? What are the three forms? The three forms are either you can have the quadratic function in general form. It can be a general form. Or you can have the vertex form, or you can have vertex form, or you can have root form, Okay. So what is general form? What is the general form? The general form of a quadratic function, is y equal to ax² plus bx plus c. What is the vertex form? The vertex form is a times x minus h whole square plus k. Where h and k are nothing but the vertex of the quadratic function or the parabola. Okay, so I'll write here h comma k is the vertex. So h comma k is nothing but the coordinate of vertex. Okay, now the root form. How does the root form looks like? So it is a times x minus r1 and x minus r2. What is r1 and r2? R1 and r2 are roots of the function, or you can say r1 and r2 are roots. You can say roots, or you can say zeros, or you can say x-intercept. As well. Okay, So basically these are the three general form of a quadratic function. These are the three general form of a quadratic function. Okay, now let's discuss the three forms of the quadratic function in detail. Okay, your first form is general form of a quadratic equation. General form of a quadratic function. Quadratic function. What is the general form? What is the general form? The general form is y equal to ax square plus bx plus c. Ax square plus bx plus c. So what I mean to say is, let's say you have a parabola. Let's say you have a parabola which passes through, let's say, a point minus 1 and 12, 2 and 6, let's say, 2 and 6, and let's say the third point is 3 comma 12. Okay, so let's say, okay, maybe this point could be, I mean, this point could be anywhere. So guys, the thing that I want to say here is the graph is not drawn to the scale, but the important point here is it is passing through this point and this point. Okay, and now you have to find the quadratic function out of this information. So how do you find it? You substitute these points in the general form and then you get the answer. What I mean to say is y equal to ax square plus bx plus c. I'll substitute the point minus 1 comma 12. So I'll substitute x value. I'll substitute the x value as minus 1 and I'll substitute the y value as 12. Okay. Similarly, I'll do for the other two also. So if I do that, what do I get? I get 12 equal to a times minus 1 whole square plus b times minus 1 plus c. So 12 equal to a minus b plus c. Let's say this is your first equation. Now let us substitute this point. Let us substitute this point 2 comma 6. So what will be your equation? What will be your, of course, equation, not my fault. So equation will be 6 equal to a times 2 square plus b times 2 plus c. Okay, now let us simplify. So this becomes 6 equal to 4a plus 2b plus c. So this is, let's say, your second equation. And let's say if I substitute the third point also, what will it be? It will be 12 equal to a times 3 square plus b times 3 plus c. Okay, so it becomes 12 equal to 9a plus 3b plus c. So this is your equation number 3. So basically we have three equations. The first equation is a minus b plus c equal to 12, which I took from here. Now the second equation is this. What is the second equation? It is 4a plus 2b plus c equal to 6. Okay, now let us subtract. Let's say this is your equation number 1. Let's say this is your equation number 2. Now let us subtract equation 2 minus equation 1. Let us subtract equation 2 minus equation 1. So 4a minus a will be 3a. 4a minus a will be 3a. Then 2b minus of b. 2b minus of b will be 2b plus b, 3b. It will be 3b plus 3b. And c minus c will be 0. And then lastly 6 minus 12 will be minus 6. 6 minus 12 will be minus 6. Now what I can do is I can simplify this 3 times, and then 3 times 1, 3 times 1 and 3 times 2. So basically it becomes a plus b equal to negative 2. A plus b equal to negative 2. Now let's say this is an equation that I'm going to use later. Now again, if you observe, I have one more equation here. Which is this. So let me write this equation and this equation. So we have 9a plus 3b plus c equal to 12. Okay, I hope it is correct. Yeah, it is correct. And the second equation is 4a plus 2b plus c equal to 6. I took this equation and that equation. Okay, now let us subtract these equations. What do you get? 9a minus 4a will be 5a plus plus 3b minus 2b. 3b minus 2b will be b, and then c minus c is 0. So you get 12 minus 6 as 6. You get 12 minus 6 as 6. 12 minus 6 as 6. Okay. Now you have two equations again. You have this equation, you have this equation. Let us subtract them. So you have 5a plus b equals to 6. You have a plus b equal to minus 2. Let us subtract them. So you get 5a minus a as 4a. B minus b will be 0 and equal to 6 minus minus 2 will be 8. 6 minus minus 2 equal to 8. So a is 2. A is 2. Now if you substitute it over here, then a plus b equal to minus 2. 2 plus b equal to minus 2. B equal to minus 4. B is minus 4. A is 2. Now you had a very interesting equation which was here. A minus b plus c equal to 12. So I'll write it here. A minus b plus c equal to 12 equal to 12. Now you have a equal to 2, you have b equal to minus 4. Let us substitute. So a equal to 2 minus minus 4 plus c equal to 12. So 2 minus minus 4 is 2 plus 4, which is 6. So 6 plus c equal to 12. So c equal to 12 minus 6 is 6. Okay. So what did you get as the answer? The question, the thing was ax square plus bx plus c equal to y. So what is a? A is 2, b is negative 4 and c is 6. So the answer will be 2x square minus 4x plus 6 equal to y. So this is how you get the quadratic function if 3 points are given. So let's say if you have a graph, on that graph, if you have 3 points from where the quadratic curve is passing, if you know that there are 3 points from where the quadratic curve is passing, if you substitute those 3 points in the equation, if you substitute those 3 points in this equation in place of x and y, you get 3 equations and you have 3 unknowns. Either you put it on your calculator, go to nsolve, put those 3 equations and you will get the 3 values, or you can solve it manually the way I have solved it for you, and that's how you get an equation from that given information. Okay. Now we are going to discuss the second form of a quadratic function, which is vertex form of a quadratic function. Okay guys, now how does the vertex form looks like? How does it look like? So y equal to a times x minus h whole square plus k. This is how the vertex form look like, where h comma k, where h and k is nothing but the coordinates of vertex. So h comma k is nothing but the coordinates of vertex. So I'll give you an example. Let's say you have a quadratic curve something like this, with the vertex minus 2 and 3, and we have one more information. The graph is passing through minus 5 and 10. Now using this information, how can I get the quadratic function? So guys, the quadratic function is, the vertex form of the quadratic function is y equal to a times x minus h whole square plus k. Okay, what is h and k? H is minus 2, and what is k? K is 3. So let us substitute. So you will get y equal to a times x minus minus 2, right? X minus h is minus 2 plus k is 3. So it becomes, and this is whole square by the way, so it becomes y equal to a times x plus 2 whole square plus 3. Now we still need to find the value of a. So how do I find the value of a? We have one more information, and the information is that the curve is passing through minus 5 comma 10. So let us substitute this point in the function and let's get the value of a. So guys, it will be 10 equal to a times x, which is minus 5 plus 2 whole square plus 3. Okay, so how do I solve it? Now 10 and this is 3, so let's move 3 on the other side. Let's move 3 on the other side. So it becomes 10 minus 3 7, it becomes 7 equal to a times minus 5 plus 2. Minus 5 plus 2 will be minus 3 whole square. Minus 3 whole square. Okay, so 7 equal to minus 3 whole square is 9. So 9 times a, 9 times a, and a will be equal to 7 over 9. A will be equal to 7 over 9. So what does my quadratic function look like? So my quadratic function ultimately is y equal to a, which is 7 upon 9 times x plus 2 whole square, x plus 2 whole square plus 3, x plus 2 whole square plus 3. So this is how, I'm so sorry if you can't see this. Yeah, so this is how you get the quadratic function from the given information, So I would like you all to see this, have a glance over the whole process that I've used. You can pause the video and then you can see. I have substituted the value of vertex in the general form, not in the general form, in the vertex form, which is this. I've substituted the value of vertex. Then I had to find the value of a. So I substituted this point. Minus 5 comma 10 in x and y, and then that's how I got the value of a, and that's how I got the entire function. Now we are going to discuss the third form. Of a quadratic function, which is root form. Of a quadratic function. Okay, so what is the root form of the quadratic function? It looks like y equal to a times x minus r1 and x minus r2, where where r1 and r2 are nothing but the roots of the quadratic function. I'll give you an example. Let's say you have a quadratic curve something like this. And it has two roots. Let's say it has two roots. I'll draw the Cartesian plane if you wish. Let's say the graph looks something like this. This is your y-axis, this is your x-axis. And let's say you have two roots. One is this and one is that. So let's say this point is 1, 0 and the other point is 3, 0. So how do I get the quadratic function from this given information? Okay, so let us use the root form. We know that the value of r1 is 1, and the value of r2 is 3. So let's plug in those values. So y equal to a times x minus 1 into x minus 3. Okay, I need one more information. Let's say the graph is passing through. Over here. Let's say the graph is something like this. Yeah. And let's say it is passing through 0, 3. So this is the information that you have. You have two roots and you have a point from where the graph is passing through. Okay. So I have the quadratic function, but a is still unknown. So how do I find the value of a? If you observe, we know that it is passing through a point 0, 3. So let us substitute x as 0 and y as 3. So 3 equal to a times 0 minus 1 into 0 minus 3. So 3 equal to a times minus 1 into minus 3. So 3 equal to 3a and a equal to 1. Which means your quadratic function will be y equal to 1 times x minus 1 and x minus 3. This is your quadratic function. So this is how you do it. If you want, you can go through the process. What is the first thing? The first thing first is you observe the roots. You observe the roots, which is 1, 0 and 3, 0. Once you observe the roots, then you substitute it over here. Once you have substituted that, then you will have to find the value of a. How do I find the value of a? There will be 101% one more point given from where your graph passes. Luckily in this question, the graph was passing through 0, 3, which is the y-intercept, so it becomes very easy to solve. In other cases, it can be some other point also. It can have some other point also, okay? So this is how you get the quadratic function by root form, right? Using root form, okay? Now we are going to learn how to draw the quadratic function. I have 3 methods to do it. Let's discuss all of them. So method 1 of drawing the quadratic function. The first method is known as intercept method. Okay. So what does it mean? Let's say you have a quadratic function which is y equal to x square minus 4x plus 3. You have to sketch the graph of this quadratic function. So what does the intercept method say? The intercept method say is your first step. Your step number 1 is to find the x-intercept and y-intercept. So what is the y-intercept? To find the y-intercept, you substitute x as 0. So y equal to 0 square minus 4 times 0 plus 3. So 0 square is 0, 4 into 0 is 0, so 0 plus 0 is 0 and plus 3 is 3. Okay, so y-intercept is 3. So y-intercept is 3. Okay, now find the x-intercept, that's your second step. Second step is find the oh sorry, it's not the second step, it's the first step only. I found out the y-intercept, now I have to find the x-intercept. How do I find x-intercept? I substitute y as 0. So x square minus 4x plus 3 equal to 0. So if I factorize this, if I split the middle term, it will be x square minus 3x minus x plus 3 equal to 0. So x times x minus 3 minus 1 times x minus 3 equal to 0. So from the whole expression I am taking x minus 3 common. So it becomes x minus 3 times x minus 1 equal to 0. Okay, I hope you know how to factorize the quadratic function. If you don't know it, please comment in the comment section and I'll help you out. Okay, so basically x minus 3 is 0 or x minus 1 is equal to 0. So x is either 3 or x is equal to 1. X is either 3 or x is 1. So you got the x-intercept also. Your y-intercept is 3, your x-intercept is 3 and 1. Okay, so what do? I make the Cartesian plane first. Let's say this is your y-axis, this is your x-axis, and that's your origin. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3. So 1, 2, 3, 4, and 5. Then this is 1, 2, 3, 4, and 5. This is, let's say, minus 1, minus 2, minus 3. Okay. So guys, you have 3 points. You have y-intercept as 3, so 0, 3. You have x-intercepts as 1 and 3. 1 and 3. So 1 and 3. Now the thing is, you can join the curve and make a parabola, but we do not know the turning point. So it is very important that we know the turning point. Now how do I find the turning point? If you remember, I taught you that any quadratic curve is symmetrical with respect to axis of symmetry, and axis of symmetry is exactly in the center of the graph. It is exactly in the center of the parabolic curve. Okay, so since I have the two roots, which is 3 and 1, I can easily find the axis of symmetry. So how do I find the axis of symmetry? I can find axis of symmetry as x equal to 1 plus 3 divided by 2. Whatever the two roots are, you add them and you divide them by 2. So x equal to 4 by 2, x equal to 2, x equal to 2. So x equal to 2 will be the line which will be parallel to y-axis. So let's say this is your axis of symmetry. Somewhere on the axis of symmetry, your graph's vertex will lie. Somewhere on the axis of symmetry, the vertex of the graph will lie. So if I know the quadratic function is y equal to x square minus 4x plus 3. If I know that x is equal to 2, it simply means that the vertex, the x coordinate of the vertex will also be 2. The x coordinate of the vertex is also 2. So let us substitute it over here. So you get y equal to 2 square minus 4 times 2 plus 3. So y equal to 4 minus 8 plus 3 y equal to 4 minus 8 is minus 4, minus 4 plus 3 is minus 1, so this is minus 1. Okay, so I know that for x equal to 2 and y equal to minus 1, my vertex will lie, right? So x equal to 2, which is here, and then x equal to minus 1, which will be here, right? So now you have these points, just join them and you will get the curve. Let us join them and you will get the quadratic curve. So it looks like V, but it's actually U. It's actually a parabola. It's not drawn to the scale, so don't worry. So let us summarize. How to find, how to draw the graph using intercept method. Step number 1, find x-intercept and y-intercept. Step number 2 is find the axis of symmetry, which is x1 plus x2 by 2. It will be, or whatever your roots are, r1 plus r2 by 2. Okay, r1 and r2 are your roots or x-intercepts. And third point is find the vertex. Okay, so you will have these 3-4 points on your graph paper and then join them. Lastly, join them. Once you join, you get the quadratic curve. Now we are going to discuss the second method to draw the quadratic function. What is your second method? The second method is turning point method. Okay, what is the turning point method? Let's say you have a function y equal to x square minus 4x plus 3. Okay, now what are we going to do? Step number 1, we are going to complete the square. Use the completing the square method. Complete the square. In case if you don't know how to use completing the square method, I have made a video on it. You can go on my channel and check it out. Okay, so you have x square minus 4x plus 3. Put these two guys in jail, in brackets. And then square root of x square is x, half of 4 is 2, and then sign between them, the sign between them is negative, so x minus 2 whole square, and you always subtract this square, so minus 2 square, and then we had plus 3 as it is, so plus 3. This is equal to y. So it becomes y equal to x minus 2 whole square minus 4 plus 3. So y equal to x minus 2 whole square minus 1. Okay. Now if you remember the vertex form of a quadratic function, you will realize that this is 2 and this is minus 1. This is nothing but the coordinate of vertex. So I'll draw the Cartesian plane. Let's say 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. Okay, so I'll quickly mark it. I'll quickly label it. 1, 2, 3, 4. 1, 2, 3, 4. Minus 1, minus 2. Okay, so I know the coordinates of vertex. The coordinate of the vertex is 2, minus 1. The coordinate of the vertex is 2, minus 1. So it will be somewhere here. Okay, so let's say it is here. 2, minus 1. Now the next point that I wish to draw is the y-intercept. So second step is find y-intercept. What is the y-intercept? The equation was x square minus 4x plus 3. If you substitute x as 0, it becomes 0 square minus 4 times 0 plus 3. So the y-intercept ultimately will be just 3. I have substituted x as 0. So y-intercept that I get from here is 3. Okay, so y-intercept is here, it is 3. Now since you know the coordinates of vertex, you will also know that the axis of symmetry is passing through the vertex. Okay, so guys, let's say this point is 2. I'll erase it. I'll draw it properly. Hold on. Okay, so let's say it looks something like this. So this point is 2. And then I'll draw the axis of symmetry. It looks something like this. Now the thing is, we have the axis of symmetry. So let's say if this distance is d, then at the same distance on the right hand side we will have one more point. Right? So let us join these 3 points. Let us join these 3 points and you will get the answer. So let us join these 3 points, and this is how your quadratic curve will look like. Now my question is, how do you find this point? How do you find this point? So if you noticed, this distance over here is how many units? 2 units, right? So this distance over here will also be 2. So the point will be 2 comma 2 plus 2, 4 comma 3. The point here will be 4 comma 3. I mean, no one is asking you right now how to find that point, but you should know. You should know. So this is how you draw the quadratic curve. This is how you draw the quadratic curve. So let us summarize. Let us summarize. So step number 1 is completing the square method. Use completing the square method to find vertex. To find vertex. Okay. Step number 2 is find the y-intercept. Find the y-intercept. And step number 3 is find the symmetrical point. Find the symmetrical point. What I mean to say over here is, you had the y-intercept, right? You already had the y-intercept, which is here. Then I found out one more point which is at the same distance towards the right. So from the axis of symmetry, towards the left is your y-intercept, and towards right you will have one more point which will be symmetrical. So using symmetry you can find one more point which is, let's say, 4 comma 3. And once you find the symmetrical point, you have to join those 3 points and you will get the graph. You have to join those 3 points and you will get the quadratic curve. So very easy, guys, very easy. Now we will learn one more method, method number 3, to know how to draw the quadratic curve. So method number 3 is the formula method, or let's say trick method. Formula or trick method to draw a quadratic function. Okay, very easy, guys. Always remember that any quadratic function can be written as Ax² plus Bx plus C. Okay, now instead of you finding the vertex using completing the square method, it is even easier to find the vertex by using the formula. So the x coordinate of vertex is given by minus b by 2a. It's given by minus b by 2a. Let's take an example. Let's say you have a quadratic function y equal to x² minus 4x plus 3. Okay. Now guys, a is 1 here, b is minus 4, and c is 3. So what will be the x coordinate of vertex? It will be minus b upon 2a. So minus of minus 4 upon 2 times 1 is minus of minus 4 is positive 4. Positive 4 divided by 2 is 2. So it is 2. Now let us substitute this value of 2 over here in place of x, so that we can find the y coordinate of the vertex. So what will be the y coordinate of the vertex? The y coordinate of the vertex will be 2 square minus 4 times 2 plus 3. So 4 minus 8 plus 3, which is negative 1. So now I directly have the coordinate of the vertex. What is the coordinate of the vertex? It is 2 comma minus 1. Okay. So let us draw the Cartesian plane. I'll draw it here. Okay, let's say 1 2 3 4, 1 2 3, 1 2 3 4. Okay, let me quickly label it. This is your y-axis, this is your x-axis. This is 1 2 3 4, minus 1 minus 2 minus 3, 1 2 3 4. So the coordinate of the vertex is 2 comma minus 1. So 2 comma minus 1. Okay, I think I'll use another ink maybe. Yeah, very congested where it is here. 2 comma minus 1 is here. Let's say this point over here is 2 comma minus 1, is 2 comma negative 1. Now I need 2 more points. Okay, so the first point is find the y-intercept. That's your second step. Second step is find y-intercept. Now you had y equal to x² minus 4x plus 3. If you substitute x as 0, you get the y-intercept. So when you do that, your y-intercept will come out to be 3. Y-intercept will be 3. So let us mark that point also. Now, since you know the axis of symmetry, since you know the vertex, you will also know that the axis of symmetry passes through the vertex. So this will be your axis of symmetry. Okay, so I have a point towards the left of the axis of symmetry at, let's say, d distance. So I will have one more points towards the right of the axis of symmetry at d distance. Okay, so what will be this point? This distance over here is 2. This distance over here is 2. So what will be this distance? What will be this distance? It will be 2 again. So 2 plus 2, 4. What I mean to say is this point over here is 2 comma 0. So you go towards right of 2 by 2 units. So 2 plus 2, 4. I hope you understood. If not, please comment in the comment section. So I get one more point, which is this, which will be 4 comma 3, and then you join the points. Then what do? You just join the points. So the graph will look something like this. Okay, and that's how you get the quadratic curve. So these are the three methods using which we can draw the quadratic curve. Apart from this, there is nothing in quadratic function, though there are many things in quadratic equation. So I'm going to make one more video on quadratic equation, quadratic inequalities. But for this video, that's it. I hope you understood how to draw the quadratic function, and I hope you learned a lot of things. And if you have liked the video, please if you have liked my teaching, so please like the video, share it with your friends, and subscribe the channel. Thank you so much. That's it for this video. Thank you.